Hello everyone, welcome to Digital Lesson for Students by Department of School Education, Nagaland. I am T. Pungri, MSc MPhil Mathematics from C.D. King Higher Secondary School, Jatsama, Kohima. In the last session, we learned what is a function and what are its types. And in this session, we are going to learn composition of functions and invertible function. It's a very important topic. You will be getting 4 mark question every year. And composition of functions. If you take two functions, f and g, f is a function from a to b. See, f is a function from a to b and g is a function from b to c. Okay. Then we can find the composition of these two functions as, that is from a to c, we denote it as GOF. Okay, it is defined as g of f of x. Alright. See, when you take an element x in a, when it goes under the function f, it becomes fx. That is our range. And when this fx, with this element, when we operate a function g on it, then it gives us gfx, isn't it? So this composition will be, the x will be related with gfx. Okay, so it is a very simple. We can see an example also. Like every one of you will be writing your board examination. In there, you will be assigned a roll number, right? So you are assigned a roll number, that is the function f. So this is your roll number, and to maintain the confidentiality, the board will assign again the roll for every roll number. They will assign a code number and give it to the examiners. Okay, so that is our function g. So every student is assigned a roll number, and then the roll number is assigned a code number again and given to the examiners. So we are composing the two functions into, that is every student is given a code number, that we can say that g of fx equal to g of f of x. In this case, the very important condition should be range of the function f should be a subset of domain g for g of f exists. Okay, if range f is a subset of domain g, then g of f exists. Suppose if range g is a subset of domain f, then f of g exists. These are important conditions. It might come for MCQs also. And range f, if it is a subset of domain f, then f of f exists. Okay, we are defining on the same set. This f of f is not equal to ff. Okay, ff is f of x into f of x, multiplication of functions. You studied last year, right? So this is not same. Don't get confused with these two. Okay, right? Okay. And in general, g of f will not be equal to f of g. Okay. You have to remember these conditions and this definition. Okay. Now let us see an example. If g of x is defined as x squared plus 4 and fx is defined as 3x plus 2. Okay, how to find f of g or g of f? So let me do g of f. G of fx will be written as g of fx. Please remember, when we find g of f, we have to operate f first and then we go to g. And f of g, we operate g first and then we go to f. Okay, from the right to left. Okay, then g of fx is what? 3x plus 2. 3x plus 2. Now this will be taken as x here. So in place of x we have 3x plus 2, right? So you replace x with 3x plus 2 here. Then this will be 3x plus 2 whole square plus 4. If you simplify it, you get 9x squared plus 4 plus 6x plus 4. So that is 9x squared plus 6x plus 8, right? Then how to find f of g? F of gx is f of g of x. So that is f of g of x is x squared plus 4. Then you replace x here with this x squared plus 4. Then 3 times x squared plus 4 plus 2. That is 3x squared plus 12 plus 2. So that is 3x squared plus 14. Okay, see, g of f is not equal to f of g. Alright. Then we will go to the basic definition of identity function. Identity function. You studied last year identity function. if I is a function from A on to A onto A, if it is defined as I of A, maybe I will take F here, F A is A, or if you take X, then you get Fx equal to X. Hope you remember this one, last year we studied. For every X belongs to A, then we call this function as identity function. That is, the function identifies every element with itself. Okay, so if you give A has 1, 2, 3, 1, 2, 3, then if you put F1 will be 1, F2 will be 2, and F3 will be 3, right? So the element takes itself, right? We get the same number. Therefore, this type of function is called identity function. Okay, the next one, if you take an one-to-one and onto function, let us define two functions f and g as f is a function from A to B and g is a function from B to A, right? And f is one-to-one and onto. This is important condition. Then A has the elements 1, 2, 3 and B has the elements A, B, C. And F1 will be A, F2 will be C, F3 will be C, and then GA will be 1 and GB will be 2 and GC will be 3. Okay, if we could find out GOF, right, GOFX, right, we are going to find out this. That's why GOF of 1, because this X from the F function only, F starts from A, right, A has 1, 2, 3. So we have to start with these elements 1, it gives us G of F of 1, right, and F of 1 is A again, G of A, right, F of 1 is A, therefore G of A is 1. So when you take 1, you get the answer as 1. Alright, then GOF of 2. So we get G of F2 will be, G of F2 is B. So G of B is 2. When you take 2, you get the 2 as your output. And then GOF3 is G of F3. So F3 is equal to C. Therefore, G of C is again 3, right? So when you take 1, when you give input 1, you get 1 as output. When you give 2 as input, you get 2 as output. And 3 as input and then 3 as output. So in this case, in general, we can say that GOF is nothing but identity function on the set A, because 1, 2, 3 belong to A, right? Okay. Similarly, if you can find out FOG, we will get FOG will be IB. That is the identity function on B. Okay. So these two are important conditions when F is 1 to 1. Okay. If F is 1 to 1 and onto, it will satisfy this condition. GOF is IA and FOG is IB. And if GOF is equal to IA and FOG is IB, then F will be 1 to 1 and onto. This is if and one if condition. Okay. In this case, if you could find F is a function from A to B, and if you could find a function G from B to A. See, we are just switching the sets right here. A goes here and B becomes its domain. If we can find a function like this, such that GOF, if you get identity function on A and FOG is an identity function of B, then G is called the inverse of F, and F is said to be invertible. Alright, you will be having a question in the exercises that is prove that F is invertible or F has inverse. Okay, so G is the inverse of F, otherwise you can denote this G as F inverse also. Okay, F inverse. Here if you define fx equal to y, then f inverse, this g is equal to f inverse, right? Then f inverse of y will be equal to x. Okay. G is invertible, f is invertible or f has inverse. There will be a question like this. And find the inverse of A also. This is one method of finding the inverse. Okay. You have to, if you could show that GOF is equal to IA and FOG equal to IB, then F is invertible and G is the inverse of F. We can prove like that. Otherwise, F is invertible because already we have seen that these two to exist, it should be 1 to 1 and on to, right? So the same condition we can use it for the invertible also. F is invertible if and only if F is 1 to 1 and on to. Okay, either by this or by this we can prove that F is invertible or F has inverse, and we can find the inverse of F also. Okay, so this one we have already seen in the last session, how to prove F is 1 to 1 and on to. Then if you could prove that F is 1 to 1 and on to, then we can easily conclude that F is invertible, and I will tell you how to find the inverse also. Now I am going to show a problem by this method. Okay, GOF equal to IA and FOG equal to IB, which is comfortable for you, you can follow that method. Here you see that problem. Consider F is a function from R plus to 4 comma infinity. R plus represent the positive real numbers to the interval 4 comma infinity, that is greater than or equal to 4, given by fx equal to x squared plus 4. Show that F is invertible. So we have to prove that F is invertible either by proving that GOF is IA or FOG equal to IB. A represent this set and B represent this set. Okay, or we can show that F is 1 to 1 and on to. In that way also we can prove it. Then with the inverse F inverse of F given by the inverse also given. Okay, but whether we have to check whether this is the inverse or not, where R plus is the set of all non-negative real numbers. Okay, first I will show you it is 1 to 1 and on to, then I will show the other method also. Okay, so given F function from R plus to 4 comma infinity, defined as fx is equal to x squared plus 4. Okay, first let us show that it is 1 to 1. For that we have to consider two elements. Consider x1 and x2 from the first set. What is the first set? R plus. Alright. Okay, suppose we are going to follow the contrapositive rule. Hope you remember. Fx1 is equal to fx2. Suppose if it is true, then this gives us x1 squared plus 4 is equal to x2 squared plus 4, right? Okay, since fx equal to x squared plus 4, and then 4 we can cancel it, and then x1 square minus x2 square equal to 0, a square minus b square, x1 plus x2 into x1 minus x2 equal to 0. This cannot be 0 because if you take x1 plus x2 is 0, then we get x1 equal to minus x2, right? But what we are considering in the domain, x1, x2 we are taking from the domain, right? So what is our domain? Positive real numbers. But it is showing that this x1 is equal to some negative number. It is not possible. So we are going to neglect this and we take the other one, that is x1 minus x2 equal to 0, and here x1 is equal to x2. Therefore, f is 1 to 1. We have shown that f is 1 to 1. Then we will show that f is on to. Okay, let y belongs to, we have to take it from the second set. What is our second set? Let y equal to, we have to prove that this y belongs to the second set. Let us take y equal to fx, that is equal to x squared plus 4. Right, we will consider like this, and then y equal to x squared plus 4, then y minus 4 is x squared. We can write this one as x squared equal to y minus 4, then x equal to plus or minus root over y minus 4. Here we will neglect this minus as we are dealing with only the positive numbers. So we will take only the positive y minus 4 root over 5 y minus 4. Okay. So it is very clear that y we can take only the values from 4 and above, isn't it? If you take less than 4, if you give less than 4 values for this y, what will become? Suppose if you take 1, then it will become 1 minus 4, that is minus root 3. This is not a real number, it is a complex number, right? But we are dealing with only the real numbers. Therefore, it cannot be. So y must be belonging to 4 and above. Therefore, we can conclude that it is meaningful, and for every y value we get an x value, right? Okay, so for every y belongs to 4 comma infinity, this is our codomain, we get there exists an x in the domain. Domain is our R plus, such that it satisfies this fx equal to y. Okay, therefore f is onto. This is how we prove it is onto for every function you get. Okay, here it is 1 to 1 and onto. Therefore, f is 1 to 1 and onto. Therefore, f is invertible. Then what will be its inverse? F inverse will be nothing but what you get for x. This is your inverse. Okay, so f inverse of y. F inverse of y is x, that is root over y minus 4. So that is given here, f inverse of y is root over y minus 4. We get the same inverse, right? Okay, this is one way of finding the inverse. Then the other one is the other method. You can do either the first one or by the second one. Okay, let us define first of all from the fx. Now you take y equal to fx, that is equal to x squared plus 4, and if you rewrite you get x equal to root over y minus 4, right? First you find out this, and then let us define a function g from g is our inverse function, right? So we have to switch these two from 4 comma infinity to r plus as g of y. To know the difference, I am using the letter y. Okay, g of y, that is equal to root over y minus 4. We consider this one as our function here. G of y equal to root over y minus 4. Okay, then let us find out g o f. G o f x. X we take from f, so I am putting x here. Then this is written as g of fx. Okay, then g of fx is x squared plus 4. X squared plus 4. Then in g of y, that is root over y minus 4, right? So root over x squared plus 4 minus 4. So if you simplify, you get x. So what you get? G o f x equal to x. That is g o f equal to I a, the first set, right? Okay, a. And f o g of y, that is f of g of y. So that is f of g of y is root over y minus 4. So that is, if you replace x with root over y minus 4 here, what do we get? Root over y minus 4 whole square plus 4. Then the root and square will get cancelled. Y minus 4 plus 4, that is y. So when you take f o g of y, you get y. Therefore f o g is equal to ib, right? Okay, if it is true, we could prove this. Therefore f is invertible. And what is the inverse? F inverse of y is g of y only, right? So g of y is root over y minus 4. By this way or the previous method, you can find the solution. So you will get 4 mark question of this type. That's all. Thank you.